So program synthesis is that typically you give a computer some hints and say, I want a function, and if I give it the empty list, it should produce the empty list. And if I give it the list 1, 2, 3, I want the list 3, 2, 1. Can you find a function that behaves like that? And then there's this huge space of all possible programs. And there the computer does the hard work, and it searches the massive search space of every list processing program that you can imagine, and then picks one which kind of meets it, which satisfies these tests. Or you can provide different kinds of inputs, but it's really the computer which is doing the hard work in a way.
Right.
So program calculation, for me at least, is that you have a calculus that kind of a set of rules where you start with a specification, and you so one of the nicer, or maybe nicest, frameworks for program calculation is actually the refinement calculus by Carol Morgan, and various other people have worked on this, which is very much in an imperative setting, but it's very clearly in kind of equational reasoning approach, where you start with your pre and post condition, which says something or another, and then you say, well, I'm allowed to do this rule where I start by assigning x becomes 17, and then I'm left with a new pre and post condition for the remaining program that I need to write. Or I can introduce a conditional, and then I have to figure out the then branch and the else branch, and I have a little bit of more information in the conditional because I branched on whether y was 12 or not, right? And then in this way, you can, the pre and post condition of the remaining problem that you have to solve, it kind of hopefully becomes easier and easier as you kind of as you work your way down through, starting from your specification to what become the leaves of your abstract syntax tree. So you start with just specification, then you add program fragments, and then the specification hopefully becomes simpler, and then you kind of go through all these moves, and then you're left with something which is kind of trivially true, or a specification which is obviously easy to solve with a single assignment or something. And then the hard part is always loops and loop invariants, of course. But that's a really, really nice little framework for doing program calculation. It really gives you a calculus, a set of rules, and a system in which you can invent your own rules and things like that, and justify them.